Hey, this is Miss Prater. This is a help video for the 6.15 unit test part 2, which is your teacher graded assignment. This TGA has 3 problems, and I have made up 3 similar problems to the problems that are on your TGA. So I'm just going to go through these 3 with you. A fair coin is tossed 2 times. If X is the number of tails, that's going to be important. Find the probability of getting 0 tails, 1 tail, or 2 tails. A says, first start by drawing a tree diagram showing your possible outcomes. So we could toss a head first and then a tail, or you could put tail and then a head, it won't matter. And then we're going to toss again. So we could get a head or a tails. And then if we tossed a tail first, then we would draw 2 branches from that, and we could get a head or a tail. And then we'll look at each outcome, each possibility. So I could get a head and a head. So I'm going to do H, H. I could get a head and then a tails. I could get a tails and then a head. Or I could get a tail and a tail. And then down here, I want to do the probability of a head. Okay. Since there's 1 head and there's 2 sides, it's going to be 1/2. Sometimes they tell you a different probability. So if you're not doing a coin problem, they'll tell you the probability of whatever that you're doing in the problem. So for this problem, the probability of a head is 1/2. And for this problem, the probability of a tail is 1/2. But every probability is not going to be 1/2. So read your number 1 carefully, and they're going to tell you the probability of each. So of getting a head, so this is a head and a head. So remember, when we have an and, we multiply. So this is going to be 1/2 times 1/2, which is 1/4. This is going to be a head times a tail. So this is going to be a 1/2 again times a 1/2. It's not always going to be a 1/2 and a 1/2. It may be 2 other decimals or 2 other fractions. A tail and a head will also be a 1/2 times a 1/2. And then a tail and a tail would be 1/2 times 1/2. Because we have that and, that's when we multiply the probabilities. If we had an or, then we would add. Now I am going to change all these to decimals just because I think decimals are a little bit easier. So 1 divided by 4 is 0.25. So we'll change all these to be 0.25 to make sure that you made no mistakes. All of these probabilities have to add up to be 1.00. I always check this to this day just to make sure I didn't make a careless mistake. Okay, so A says draw a tree diagram showing your outcomes. So here's my tree diagram. I went ahead and did a little bit of work. So actually, this is the tree diagram. This would be enough for the A part. This is just work in order to answer the B part. So the B part says create a binomial distribution for 0 tails, 1 tail, and 2 tails. So we would do X, and then we would do probability, and then we're going to do 0, and then we're going to do 1, and then we're going to do 2. So when we're doing 0 tails, remember X is tails. So if we go over here and look at our chart, the only time we have 0 tails is when we have 2 heads. And when we have 2 heads, we have a probability of 0.25. Next is the probability of 1 head. So we have both of these combinations have, 1 tail, 1 tail. Both of these combinations have 1 tail. So you're actually going to have to add these 2 up. So you're going to have to do 0.25 plus 0.25. Let me try to make that a little bit clearer. Trying to write smaller, which makes it harder. So because I have 2 combinations that are 0.25, you're going to add those. So 0.25 plus 0.25, is 0.5. So the probability of getting 1 head is 0.5. Just want to show you that you had to add those 2. And then the last one is 2 tails. And 2 tails is only going to happen once. And so that's going to be 0.25. So for 0 tails, it's 0.25. For 1 tail, it's 0.5. And for 2 tails, it's 0.25. And if I add all these up, I should also get 1.00. And that's just a double check there. So this is the probability of tails. I think I said heads a couple times, so let me just rephrase this again. The probability that I'm going to get 0 tails is happening right here when I get 2 heads. All these other combinations, I have at least 1 tail. So 0 tails would happen here, and that's a probability of 0.25. 1 tail would happen here or here. So I have to add the 2 probabilities. So 0.25 plus 0.25 gives me 0.5. And then the probability of 2 tails would happen right here. And that's 0.25. All right, moving on to number 2. It says students were asked how many hours they studied each week for Algebra 2. The frequency table shows the results of the survey. So here are my hours. So 5 students studied 0 hours, 8 students studied 1 hour, 9 students studied 2 hours, 12 students studied 3 hours, and 3 students studied 4 hours. So what I would do first, because I always forget to do this, is I would add up my frequencies to get my total number of students. So I'm going to add 5, 8, 9, 12, and 3. 5 plus 8 plus 9 plus 12 plus 3 is going to give me 37 total students. You have to know the total in order to do your probabilities. So let's just double check. 5 plus 8 is 13. 13 plus 9 is 22. 22 plus 12 is 24. Did I do that wrong? 5 plus 8 is 13. 13 plus 9 is 22. 22 plus 12 is 34. 34 plus 30 is 37. Okay. All right. A says create a probability distribution table from the frequency table. So I'm just going to draw this. It doesn't have to look beautiful. So you might want to write out your answers. You're having to draw a tree diagram for number 1. That's going to be really hard to type. So maybe you just want to write your answers out on a sheet of paper and take a picture and submit your pictures. Email your pictures to yourself. Or you can send them to your Google Drive, however you do that. So what I did is I made a chart and I did hours and then I did probability. It does tell me to round to the nearest hundredth, so that means I'm going to use decimals here. My hours are 0 hours, 1 hour, 2 hours, 3 hours, and 4 hours. So 5 people studied 0 hours, and remember that's 5 out of 37. So that's 5 out of 37. To get the decimal for that, we do top divided by bottom. And I'm rounding to the nearest hundredth, so that's 2 places to the right. So that's going to be 0.14. To find the probability of the students that studied for 1 hour, I have 8 students that studied for 1 hour. That's going to be 8 out of 37. So to find that decimal, I'm going to do 8 divided by 37. I'm going to round to the nearest hundredth, so that's going to be 0.22. To find the probability of the students that studied 2 hours, I look at my chart. That's 9 students out of 37. That's 0.24 rounded. 3 hours, 12 students studied 3 hours. That's 12 out of 37. That's 0.32 rounded. And the number that studied for 4 hours is 3 students. That's 3 out of 37. 3 divided by 37, round to the nearest hundredth, is 0.08. Now, to double check myself, these all have to add up to be 1. So I'm going to add them up very quickly just to make sure that I did not make a mistake, because I make mistakes all the time because I'm a human being. And I added them up and I got 1. Okay, so that's a check for me. That makes me feel a little bit better. All right, B says, what is the probability that students studied less than 4 hours? So less than 4 would be 3 hours, 2 hours, 1 hour, or 0 hours. So you're going to add all these probabilities up that are less than 4. So we're going to add up 0.32, 0.24, 0.22, and 0.14. And that's going to give me 0.92. C is asking me for the probability that students studied exactly 0. So you just take your probability for 0 and you just answer that one. You don't have to add anything up there because it says equals 0. And then D says, what is the probabilities that the student studied more than 2 hours? So more than 2 would be 3 or 4 hours. So I'd add up the 0.32 and the 0.08, and that's going to get me 0.4. Out of all 3 of these, number 2 to me is the easiest. Frequency tables. I mean, it's not easy, but it's just the easiest out of the 3, personally for me. Maybe not for you. All right. Number 3 is about your standard bell curve. So I did find this curve on the internet just by Googling, and I tried to find one that had 50%. So if I add the 3.1, the 34.1, the 13.6, the 2.2, and the 0.1, I should get 50%. So this would be 50% to the left of the mean. So this has all the percentages. Sometimes you get a bell curve that doesn't have them all. So I just found one that did. So you're welcome to use this bell curve to answer your number 3. So it says the number of payday candy bars are normally distributed with a mean of 350. So my mean is 350 and my standard deviation is 50. So that's important. I'm going to go ahead and go over to this bell curve, and I'm just going to put 350 in the middle, and I'm going to write my numbers like this just because I don't have a lot of room to write them left to right. My standard deviation is 50, so I'm going to add 50 when I move to the right. So I'll get 400, add 50 more, I'll get 450, add 50 more, I get 500. I'm going to subtract 50 as I go to the left, so 350 minus 50 is 300. 300 minus 50 is 250. 250 minus 50 is 200. So I've got 350 in the middle, 200 all the way to the left, 500 all the way to the right. So I'm going to do that first, okay? And then I'm going to answer their questions. So A says, what percentage of the candy bars are 300 or less? So that would be all of the percents to the left of 300. So I would add all those up. So that's 0.1 plus 2.2 plus 13.6. So that's 15.9%. B says, what percent of the candy bars are 450 or more? So 450 is here. So I'm going to add all the percentages that are more than 450. So that's 2.2 and that's 0.1. So that's going to be a total of 2.3%. And then C says, what percentage of the candy bars are 400 or fewer? So 400 is right here. Fewer would be to the left. So I've got to add 34.1, 34.1, 13.6, 2.2, and 0.1. And that gives me 84.1%. So again, to the left or fewer than 400 would be 34.1 plus 34.1. Don't forget this little 13.6, and then the 2.2 and the 0.1. And that would be how you do number 3. Hopefully this is helpful. If you have any other questions, please let me know.